on this case study. Just read this case study properly and then we will discuss more detail about all this thing. It is given to you a company manufactures two types of products, product A and B. Each unit of product requires 2 hours of labor and 1 hour of machine time. Each unit of product B requires 1 hour of labor and 3 hours of machine time. The company has 100 hours of labor and 90 hours of machine time available. Per unit of product is like profit per unit for the product A is $100 and the product B is $15. The company wants to maximize its profit. So this is one of the case scenario we all heard about this, that the company is a manufacturing company using the product tools and they have using the labor as well as the machine time when they are doing the production, as well as the profit given by the two product is given to us. Now considering this concept of linear programming, as we have just discussed about what is exactly linear programming, and now use that concept of linear programming and their constraints with the help of this case study. So what we will do, first of all, we have to make sure what is the decision. So write it with me only, decision variables. So what we have to take a decision over here. So we have to take an assumption, what we have to take, let X be the number of units of product. We have two products, right? So X be the number of units of product X or product A over here, right? And Y be the number of units of product B. So this is your decision variable. You have to make sure that everything which you have learned up in the theoretical session, you have to know how to follow them. So what is your decision variable over here? Is the decision variable that we have taken a consider as number of units by X be the product A and Y be the number of units by the product B. Now what will be the next step over here? What you feel like? Now we have decided we have some objective function, right? Follow that point only. We have no objective function. Note down over here is objective function. Now what will be the objective function? As it is given that we want to maximize our profit, right? And what will the maximization of the profit over here is, what you feel, what type of profit we want to maximize it? Definitely we were earning a profit per unit of product A. So maximizing, writing over here is maximization. We can indicate with the help of Z, right? Maximization Z is equals to 10x product X plus how much profit for 10, and this is for 15. So we write it as 15Y as we taken our unit Y for product Y, right, for product B. Now this is again the second topic. First one is your desirable variable which we have taken over here, right? Then the second one is your constraints, sorry, objective. Now your third one is the constraint. Yes, we have the limitations of constraint. What type of constraints we have limited? Labor and the machine time. So write it over here, constraints. What type of constraints? Note down. Constraints. What is the constraint? First constraint is your labor constraint. So labor constraints is how much? Again, we require 2 hours of labor for the product X and how much hours for the product Y? That is 1 hour. And we have the limitation of labor constraint is how much? 100 units. Check it again once it is given. So we use it 2x plus y is less than 100. Why you have used this? As we require the labor required 2 hours of labor and 1 hour of machine time, and the product we require 1 hour of labor. So total constraint for the labor as we have given 100, right? For X and Y, just add all the labor together for X and Y as labor is required by both. But we have the constraint related to labor that is 100 units. So we use it 2x plus y, that is should be less than 100. This is my first constraint. If I am talking about the second constraint is your machine constraint. Machine constraints. And what is the machine constraints is, we require 1 unit of product X and we require 3 units for the product Y, and the machine time is limited to 90 hours. So this is my second constraint. This is how we are formulating our situation. And the last point that is always been there, we always use that point, is a non-negative constraint. Non-negative constraints that indicates that the product X should be greater than equals to 0 and product Y should be greater than equals to 0. So this type called as the formulation of linear programming. Hope you're able to understand how we formulate the linear programming equation. We just have to make a constraints. We have to consider the scenario of the question, what the case study indicating to you. Like in this example, what type of indications are given to you? Product A and B is making two companies making a two products. So you can do in this way also A and B, and the one is using a labor, right? And they are also using the machine. So you can write down over here as in the form also. Product A requires how much labor? We require 2 hours of labor and required 1 hours of machine. Product B requires 1 hours of labor and the 3 hours of machine. But the profit, what we can say that labor constraint is always how much it is given in this question is 100. So we write it over here and 90 hours for machine. So we can write over this like constraints over here. You can make a matrix and then also you can find it. It's up to you. You have to formulate the equations. You have to show it. Now what we can show it in this way only and the profit it is given over here. One is making a profit of $10 and example B is making a profit of 50. So what we can done up over here only we are starting up. Like you just prepare the statement and now just make a matrix. How we can formulate this linear programming? Like a product A. Now you consider in this way, like constraint one is your labor, so consider it as this way. Machine is this one, considered this way, like product A and B. And one is the profit maximization, so take this values. Now what we have considered, we taken it A, product A, maintaining a unit of X and Y for B. Then write it in this way only, 2X plus 1Y, considering a row wise and it should be less than equals to 100. Considering for the machine, if you are talking about the machine, so machine constant is the 1x plus 3y is less than equals to 9. So this is the simple way also you can do in this way also labor constraint and this is your machine constraint. Right? And the most important thing is your objective maximization. What is your objective maximization? That your product 10x plus 15y. You always want to maximize this. So you can use it, your profit maximization in a value that you want this maximization value. Your profit should be more than 10x plus 15y. That is your objective over here. Right? With the objective over here, this is your constraints. And the most important, this is one constraint, labor constraint, second, and the third one is your non-negative constraint. And non-negative constraint that product X and Y should always be greater than 0. As we assuming like the product cannot be negative, so we take it in the form of X and Y. Hope you able to find out how we formulate this case study. I have one more case study for you. Let's see, are you able to do this case study now? Having a look on this case study. Okay, now work on this. Check it. Learn about this now situation and the case. What is given over you? A bakery products. Now the bakery produces two types of bread. One white bread is there, one whole white bread. That means you have two products. One, I'm just changing the color so that it may be more visible to you. That one is your white bread and another one is your whole white bread. Right. Now each loaf of a white bread is consists of 4 cups of flour and 1 tablespoon of yeast. And each loaf of whole white bread requires 3 cups of flour and 2 tablespoons of yeast. Now, bakery has some constraint that it has only 30 cups of flour available to us, and the 10 tablespoons of the yeast is there available to us. And each loaf of white bread sells at rupees dollar, sorry, $3, and each loaf of a whole white bread that sells at $2. Now you as a bakery shopper wants to maximize its revenue. So how you will solve this problem? Again, it is a concept of linear programming. This case study, the mathematical quantitative concept, you have solved it with the help of mathematical model. You prepare this in the equation form and while using formulate that equation and using the different methods like a simplex method or a graphic method, you are able to find out the value of x and y. And immediately when you are able to find out the value of x and y, you put that value in the equation and then you find out whether your value is in maximum or not. So start preparing like what we have to consider. First we have to write out the dependent variable. right? We have just a decision variable. What type of decision you have to take now? So note down over here. What is your decision variable? Again, how much units of, like we taken a units, two things are there, white bread. So X will be the unit for white bread. Here, this is one product of yours, and taking it, Y will be the unit for whole white product, whole wheat product, or a bread over here. One is your simple white bread and one is your wheat bread. So we have taken two constraints, variable X and Y. Now the next step will be, this is first point, that's a variable you have find out. Now what is the next situation for this? Again, you have to remember the point, what you have to do up in this now. Now you have to check it whether your constraints is there or not. Yes, your constraints is always there. So you can write down in the tabular form also, or immediately also you can write it, like in the symbol way. But if you make the box of tabular form, that will be help you more detail. So we're making in that way only. Okay. So first one is your white bread. Write it over here as a white bread, right? And the next one is your whole wheat bread. You can write it in a simple word also, just a wheat bread. Okay. Now, what are the table? What are the requirements for doing these products? Are what type of things you require? First, you require the flour when you are making this bread, and the next one you require a yeast, right? How much flour you require? You require 4 cups of flour for making the white bread. So write it over here as 4, and 1 tablespoon of yeast you required. So write it over as 1. And while each loaf of white bread requires 3 cups of the flour, so write it 3, and 2 tablespoons of yeast, so write it over as 2. The bakery has 30 cups of flour. So we have the limitation here, constraint. So write it over here as a constraint. How much constraint is there? 30 cups. So over here 30 cups. And the tablespoon, we have constraint again, 10 tablespoons of the yeast available. And what about the white bread? If I'm talking about the sale revenue, so profit for white bread is $3, and for the wheat bread, it always sell at a rate of $2. So this is the information given to you. You can present this information in this way in the box format, and after making this box format, you can decide up that your variables and the constraints, how can you can formulate it. Now formulate your constraints. Now it will be like very easy for you to analyze the situation. Just now put it in the equation. Your first constraint, you can put it, what constraint you can consider in this question is, first one is your constraint is related to flow, right? So fourth, as we have taken a white bread product as an X, and the whole white bread will be taken as 4. So 4x plus 3y should be less than equals to, as we have the limitation of 30 cups. For yeast we have 1x plus 2y is less than equals to 10, right? And the most important, this is your constraint, but before making any constraints, you have your objective. And over here is your objective is maximization. What is the maximization? That these products will be sold at the maximum profit. And for that, we have given 3x plus 2y. That is main objective is that you have to find out the profit, and because it is maximization, that indicates that the profit is, you have to find out the profit. Now keeping these equations, that z is equals to 3x plus 2y and the constraint, and the most important constraint, as we all remember, the first constraint is your floor, second one is your yeast, but the last and the most important thing is a non-negative constraint. Non-negative constraints, that product x and y cannot be equal to like less than 0. It always be the value in a positive way. It always be in a positive value, right? The quantity is either 0, but it cannot be a negative. So this is the way we have to present it. Either you can make it in a like a in a proper theoretical way, you can write it, but at least you know how this linear programming equation is to be formed up. That is the most.